I was going to say I work for Balsamiq, and I had the privilege to work on a greenfield project in the past few months, and today I'm going to talk about simplicity, because that's what I've been striving to obtain. Simplicity, simple, is a state in software development that takes a lot of effort to get to. It's not something you come up with. It's not easy, and we do a lot of JavaScript development. We're heavily invested in JavaScript these days because that's what all new stuff is implemented in. So both front end and server side, mostly. And JavaScript, I think, is a very interesting language today. It has a lot to offer, but it's got its problems too, as just like every language. Specifically, it suffers from dependency hell. So, how many developers here are JavaScript developers? Just a few, yeah. And so you may know that there's plenty of problems with libraries in JavaScript. For example, npm is the tool that allows you to install libraries, and the tool itself is not complex, but it yields complexity because of the way it's being used by the community. It's got tons of problems. So, for example, 72 are the dependencies that are currently listed in our package.json, which is the way you define dependencies in your Node.js application. And so of these 72 libraries, only 32 are actually features that we need in our code. 40 are sort of language helpers, because we want to write the latest ECMAScript version of JavaScript, and so you need all the bells and whistles. So Webpack and Babel and everything to write, so to speak, modern JavaScript, like they say. But the problem is that when I type npm install and fetches those 72 dependencies together with the dependencies of dependencies, I ended up with 852 libraries in my Node modules directory, which is humongous. It's like mind-boggling. So basically that means that if any of those libraries breaks in a bad way, I'm supposed to do something about it. So the nice thing about JavaScript is that every month there's something new, and so it's new, shiny, and cool technologies. But we're supposed to write code that at least lasts for 6 months. Hopefully much more than that. So we need to find a way to protect our code from this. And that libraries can change their API in a breaking way, and so what do you do with it? And you may want to replace a library because you find another one that's better at the job that it's doing, and so you want to replace it. And then how many of you know the left pad thing? Just a few, so I'll tell you very quickly. So left pad is this library that's, it's not even a library, it's a function. It's like 7 lines long, 10 lines, I don't know how long it is, very tiny. It just left pads a string. Okay, with spaces. So if you want to make the string 10 characters long, it would just add enough spaces to make it 10. And this library has been written by some guy, and it's so widely used that this guy, for some reason, one day decided to pull it off the registry, and the next day the internet was broken because nothing could compile because of this library, right? So this is a problem, and we got to find a way to solve this. So simplicity is the ultimate sophistication. Leonardo da Vinci, it's a famous quote, right? As I said, simple is a state that takes effort to get to. And if you haven't seen this talk, I highly recommend you go and watch it, because it's really, really good talk. Simple Made Easy. It's by Rick Hackey, the author of Closure Language. And I stumbled onto this talk all too recently, and it's a really good talk. It just resonated a lot with the kind of topic that I wanted to talk about, and so highly recommend it. The definition of simple that I'm going to talk about is something that's disentangled. So if your code is disentangled, then it's simple. It's simpler than a code that it's spaghetti. And writing disentangled code might mean that it's more verbose, because you may end up writing more code. But if it's disentangled, it's still better than having a very short code that does 1,000 things all tangled together that are harder to understand and harder to maintain. No surprises. It's simpler than something that maybe is cool, So you read about these cool libraries, and you read through the documentation. You say, "Oh, I didn't see this coming. This is interesting. This is smart." Well, if that surprise is something that comes back, like in 6 months when you go back to the library, maybe it can come back to haunt you. If it's not something that's something that you wouldn't expect, then maybe it's hard to work with. So no surprises, please. No magic also. I prefer something that doesn't do too much magic. Today, it's full of libraries that automatically try to figure out the way you're trying to use them and do stuff for you so that they're easier to use with. But simple is something that it's there. It's objective property of software. Easy is something that's subjective. So it's easy for me because I'm familiar with it, but it's not easy for you maybe. And so better to have something that doesn't have any magic. Maybe there's more configuration. So you have to configure your library in very verbosely. But then it's more predictable. So that's easy. And of course, the goal is long-term maintainability. That's what we're trying to do. So we want to write code that is maintainable in the long term. And so if it's simple, it's disentangled, it doesn't have surprises, no magic, then it's easier to have to maintain it. So let's make a little example. It's a little small maybe, but you don't have to read really. Redis. Redis is a technology that I really like. I think it's a brilliant piece of software. It's got a very nice API, and because it's such a simple API, most of the wrapper libraries are just simple wrappers around the API. So if you go through the README, the documentation of the library, that's pretty much what you find. And you just import the library, and you create your connection to the database, and then you set up some error handling. And then you can start querying the database with the comments of the API, like set or whatever else, get. And it's pretty simple. And by the way, almost every README that documents libraries teaches you the wrong way. So you should never write your code like you find it in the README. And I'll tell you why. So the reason is that if you write code in a naive way, this is what you may end up with. This is what I call a hairball. It's a piece of code from an old product of mine that was actually written in CoffeeScript. You don't have to understand this, but it's not even that bad. It's not like the nesting. I didn't want to point out that part, but what I want to point out is that this is definitely it's a method that's called get product IDs given items, right? So it's obviously something that does something with the logic of your code. So it's got business logic in it, right? But look what it's also got. It's got this Redis DB in it, right? So it's mixed. It's business logic mixed with the actual library code. So what happens if one day the API changes, and instead of having HM_get method lowercase, you have uppercase because the author of the library decides to make that change. Then you have to deal with it, and then you have to go and look in your code all the places where you use the APIs of that library, and that's a nightmare. Or maybe you find something, a different library that does the job better, and you want to use that one instead of this one. So it's really hard, right? So you should be careful about getting to this point. Luckily, there's a principle in software development that's called the dependency inversion principle that comes to the rescue. So it's not something new. It's really old stuff, and you may have studied this in school. You may have read it somewhere. You may not know about it. It's something you may know, but you didn't know it was called this way. So I thought it was good to make a little recap because these are really good principles.
Sorry, Stefan, can you speak a little bit louder because of the noise of the place?
I'll try. My voice is not too loud. Sorry. So the way. This is the way you have a naive dependency in your code, right? So if you follow the README of a library, this is what you're going to end up with. So you have your code, and you import the library, and you start using the library. And this, presents the problem that I was talking about. So if the library changes, you have to deal with it. Now, wouldn't it be nice? And the reason why you have to deal with it is that basically you don't own the library. You don't own the API that the library defines, right? The author does. And so they can do whatever they want. Wouldn't it be nice if we could invert that dependency and have the library instead importing your code, right? This would solve the problem, right? Because then your code would be like a box. You are, the owner, the sole owner of, and then it's a problem of the library to call your code, right? Of course, this is utopic. I mean, it can't be, right? Because the author of the library doesn't know about your code. So what you do instead is you do an adapter. You write an adapter, and the adapter pattern works this way. You have the library, and you do write code that makes use of that library, that imports that library, but you write it in a very small piece of code, in a really small module, and you call that module an adapter. And then you write the rest of your code using that adapter instead. So instead of your code, like the big bulk of the code, importing that library, you import the adapter. And the adapter is the only place where you actually do import that module, that library, that external library. So this way you solve the problem, because then the adapter just creates this thin wrapper around the library, and you export an API towards the rest of the code, and you do own that API. If the library changes, you have to deal with it, but you have to deal with it only in a very limited piece of code, which is the adapter. That's the only place in your system where you have to deal with the change of the external library. So that solves the problem. And a refinement to that is dependency injection. That's another very popular pattern. And the way it works is that if you have a library and you write an adapter for it, then you can have another library and you write another adapter for it. For example, you can have WebSockets and PubNub. And this is actually an example from our code base. We do have two different modes of operation. So in development, we use WebSockets with Socket.io, and in production, we use PubNub. And then we have two different adapters. And then you have a configuration entrypoint in your code that imports one or the other, depending on the need. And then the rest of your code is injected that adapter. So in the rest of your code, you don't even import the adapter. You're given the adapter in the prototype of your methods. So that's another very powerful pattern that solves the problem. So to recap, dependency inversion principle, it's not about inverting the actual dependency as in the import. So who does the import? That's impossible. But it's about inverting the ownership of the API and the abstractions. So, high level, if you read it up on Wikipedia, that's what you get. So high level modules should not depend on low level modules, and both should instead depend on abstractions. Because then it means that your code should depend on the abstraction of your own adapter, which is implemented in terms of the external library. So that solves the problem. And you may remember this, theoretical talk or not, but what I want you to remember is this flashy slide that I made white on purpose, because if there's one thing you want to remember is this. It's my rule of thumb. So never import a given library in more than one module. So if you have an external library, just import it in one module and keep it simple, keep it small. And very important, don't let the API escape that module. That's also very tricky part, and I will give you a little example about that, because you have to watch out for dynamism. So JavaScript is very dynamic, so it's not a statically typed language, so you can do all sort of crazy things with it. You gotta be careful. And Bunyan is one of the available libraries for doing logging. So again, it's very simple and easy to use. So you just create a logger, you configure it so you can stream the output to the console log, or you can write it on a file. And then, once you have this logger, you can just use it very simply with just calling info or debug, and it's very easy to use, right? So, but we learned the lesson. We shouldn't shouldn't import Bunyan everywhere in the code. So we should write an adapter, right? So let's write an adapter. So if we create this factory function that takes maybe the configuration of the logger, maybe the log file path, you just create the logger and then you return the logger and you call the adapter instead of importing the library. So you have the import only in one place, right? Well, not really, because if you're not careful, you're leaking out the API at that point. So if I'm returning a Bunyan logger like this, and I'm using it in my code, then I'm not really confining the API inside this module because it leaks out. So the way you can actually use Bunyan turns out to be there's very many ways to use it. So you can call info with no parameters. You can call it with one parameter, with 3 parameters, with a dictionary, with an error. You know, it will figure out how you call it. You know, it makes it easy for you. Again, you know, this easy towards simple thing, right? So because of this ease of use, then it turns out that in our code base, this is an actual example from our code base. We have, I don't know how many info calls in our code base, way too many. And one day we decided, guess what, to switch from Bunyan to Winston, which is another library, which has a different API. And that's a problem, because we cannot really replace the Bunyan log with something that comes from Winston, because we don't know how we're using the Bunyan API, and so we're not really sure if we can just brutally replace it with a different logger, right? So if we only knew how we used it, but we don't, because we just dispersed this logger in the code, and then once it's wild in the code, go figure how you used it. So a better adapter would have been this one. So instead of returning the logger, you return something else you create with the actual methods you want to use, and then you can add to these methods if you find the need for it. But at least you wrap them up in such a way that the logger never escapes this module here, never escapes the adapter, and you only use it inside these functions that you have created. So again, we are in control of our own abstraction here. And so this way, if we had done it this way, then we would have been able to easily swap it out for Winston, because it would have been enough to just keep this this abstraction, and then rewrite the implementation using Winston instead of Bunyan. Too bad. We had to find a different solution. So just remember to wrap the API as well. So just to make a list of all the adapters that we have in our projects, just to make this real thing in our code. So we have for authentication, this is really small. For authentication, we have a Stormpath adapter. Stormpath is a cool service for authentication. Go check it out. And then we have a mock adapter, because once you get into this business of writing adapters for your external dependencies, it's also very easy to create a fake one for testing. So it's also a very nice reason to use adapters. And then we have, for caching, we have the main cache functionality that's built on top of a Redis adapter. And then we have, for logging, we have the logger that's built on top of Logmatic. Logmatic is another very cool logging facility. Go check it out. And then a Winston adapter, or a Node.js colorized console logger, and a browser adapter as well for doing logging in the browser. So don't use console log in the browser. Don't. Wrap it up, because then maybe you find out that in production you want to not print stuff in the log, but maybe you want to bundle it up, and when there's a problem you want to let the user send you the bundle. So if you figure you want to do this after you've coded all the rest of the application with an adapter, you can't change your mind. Otherwise, you're stuck with the console logs. Mailing. Mailer is built on top of Postmark, another cool service. Check it out. And the mock transport for testing. So for push, we have, as I said, the PubNub and Socket.io. So we have many adapters, and there's not one single dependency, external dependency in our application that's not being wrapped inside a module that's only one. So if we want to swap out some, maybe logging, Logmatic, we don't like Logmatic anymore, that's the only place in the whole code base that we need to change. So that's really, really convenient. So if you do this, another thing you will find is that you also solve the problem of configuration of your code. So the problem I'm talking about is what I call configuration mess, and it usually goes like this. So you have an entry point in your code that looks like a mess, because the entry point of your application is the place where you tend to collect all the initialization, so the URL to your database, and then the port your server is listening to, whatever else. It all goes in the entry point, and it will eventually become a mess. So one day you wake up and you say, well, let's make a config.js file module, and let's push all the details about the configuration inside the config.js, right? So, and that's a good idea. So you have all the variables in there, and the entry point makes use of config.js. And then you find that you have different environments. So in development mode, you want to run it in a way, and in production, you want to run it differently. So you start to have if statements in your config.js, right? That check the environment. And so you basically end up having the config.js now looking like a mess. So it's really not solving the problem. And the way I solved the problem was by letting all of those adapters bubble up their configuration all the way up to the entry point. So I let my entry point be a really huge piece of code because it collects all of the configuration, but I don't let any logic be in it. I only let the configuration be in the entry point. So instead of having an entry point and striving to make that look like a run server, open close, period, instead of trying to reach that point, because that's impossible, I try to reach that point with a code that looks like this. So run server, and then I have all of the configuration of the server, which are basically the configuration of all the adapters. And because you want to run your application in different ways, then it's okay to have different entry points, like a server production, which is the code that I run in production, but then I have server Stefan, which is the way I want to run my application. Maybe my development machine, but then I also have server Luis, which is another developer. So all of these entry points are different files and different ways to run the code, and they all run a server, but with different configuration. And we don't have a config.js anymore. So again, this is all about simplicity in the sense that we're trying to disentangle the concepts in our code and keep them separate so that each part of the code has only one thing. And another big example of entanglement is an ORM. So I'm not particularly fond of ORMs. I've used them, and I keep using them because once you start using an ORM, there's no way back. And the way an ORM look like typically is that you have a node thing, like for example, that maybe contains products, and so you have node.products that as soon as you execute this attribute lookup, then it will fire up transparently for you a query in the database, and then you have a list of products in your hand, right? And then you can do fancy stuff like maybe mapping all of those products to other attribute lookups, like to fetch the list of images connected to a product. And so now you have a list of lists of images, right? And you can do fancy stuff like flatten, so you have a list of the images of the products related to that node, right? And so if you look up to the ORM documentation, they will try to sell you this concept of ORM by saying, look, it's so convenient because with just one line, you write something that otherwise would have required you to write, several lines of SQL queries. You should stop writing SQL and instead, just use an ORM so that it makes it easy, right, for you. So again, this is the same concept, right? This is easy. It doesn't mean that this is simple. It's not simple because this basically ties together the semantic of what you're trying to do with how this is done. So you're letting the ORM decide for you that you're going to execute an SQL query on attribute lookup. So this doesn't have anything to do with simplicity. It's about being easy and approachable, but then you're stuck with it. So I'm not saying you should have your code complicated. I'm saying that you should write your code in a very meaningful way. So you should have a method fetch images of products in Node that speaks. It's also one line, but then by all means you should implement it. So that's how we do database access now. So we have methods that have meaningful names, and these methods just write plain SQL queries. And welcome SQL, welcome back. So you have the trivial way to fetch a user, just one table lookup, but then you also have more complicated methods that do joins, and that's totally okay because then you can optimize. So you can do so many things that you cannot do with an ORM. And so, like, I by all means, I prefer no magic DBs. Just let's keep the DB as simple as possible. Also, because if you write it that way, it doesn't really matter who comes join the team later. They will always figure out what happens as long as they know SQL. They don't need to go and look up the documentation of an ORM. it's effective because you can optimize the queries. Otherwise, with an ORM, it's really, really hard to optimize queries. It's verbose and boring. Yes, it is. It is verbose and boring, and because of that, it's very easy to add caching on top. So one thing that I've done with this implementation of the database, I've been adding cache, an aggressive layer of caching you've done with Redis, on top of each one of those calls in the database. And that's possible because I have them all listed in the same file, and I just go, through one by one, and I cache each one of them. That's not possible with an ORM because I don't know how I'm accessing, what are the access patterns to the database in my code. So this is all really about avoiding entanglement and keeping, separate things separate. The last example I wanted to give you about something that's really entangled comes from React. So how many of you know what React is for front-end development? Not very many. It's a very cool technology for doing front-end development, and if you use React, you will find it almost as popular as the React codebase. There's this other thing that's called React Router, and React Router is a library for dealing with one-page apps. So you have a one-page app, and regardless of the URL, you're going to be served by the server always the same bundle, which is your application, and then the application reacts, renders differently depending on the URL. And then when you change, navigate the application, you have a feeling of switching to a different page, but you're not reloading the page from the server. You're just re-rendering something else. But you need something that knows how to parse the URL and maybe generate newer URLs and stuff like that, right? So React Router, that's what it does. And when I started using React, React Router wasn't there, and so I was rolling my own. And then by the time we decided to use React Router, because everybody was doing it, we also decided to use Relay, which is this other very cool technology that doesn't play very well with React Router. So somebody luckily figured it out, and there's this library that's called Relay React Router, which is even messier. So basically, this is how you define your URLs. So you have a nested structure of URL chunks, and so you have the slash, and then you have your site _10, and then maybe slash projects or slash something else. And so basically, in this little piece of code, you have many things. You have the definition of your URL space. So you have your nested parts of the URL. And then you have the React components. And there's a big assumption here, basically being that each part of the URL should be taken care of by a different component in React. And these components are supposed to be able to work in a nested way. They're supposed to play well with each other when they're nested. And then because it's relay, then we also need to specify the relay query. Otherwise, these components wouldn't know what data to render. And so you have three things that are very deeply, bound together in a way that it's impossible to disentangle if you use this solution. And in particular, I was really pissed off by the fact that I wasn't able to specify just one query for some entry points. There were some entry points that, no matter what, would go twice to the server to fetch the data. And it doesn't make any sense because you're loading one URL, you're expecting it to go to the server once. And I looked it up in the documentation several times. I looked it up in the forums. I asked the guys. They were really helpful. They told me that maybe that they knew about the issue and maybe they were solving it in the newer version of it. So I'm pretty sure they solved it by now, and I'm pretty sure it's me being stupid. So I'm not saying that this isn't good technology, but I'm saying that I had a spare weekend and I decided to roll my own. And so I said, let's just try. I've been coding Python for a number of years, and I used to remember this other way of specifying URLs, and I really liked it. So I said, well, I'll just try to roll my own and see, where we go. And so I worked for a couple of days, and I ended up with something that looks like this. So I have this JSON that I used to define my URL entry points. And so, it's parametric, so I can specify, the parameters I want. Each route has a name that I can refer to when I want to generate them. And then for each route, I can specify the React component that's supposed to render the page, and the relay query that's supposed to feed the data to that component. So this way, I solve the problem of having a URL space that's inherently nested, because I can replace, for example, site_10/projects. I can make it _projects instead of /projects if I want to. I just replace this character over here, and I don't need them to be necessarily nested. So that's that thing I solved. I solved the problem of having React components that need to work in a nested way, because I don't have nested components anymore. I only have the page component. And then if I decide to implement that component in a way that it's nested with others, then I'm free to do that. But if I don't want to, then I'm free to choose. And I also resolved the problem of the relay query, because now I can specify only one query and I don't have two. So that solved my problem. And it's based on rules, and these little chunks that I just showed you are the rules that define the system. And I was looking at these rules and I was like, well, I can actually do more than that. I can actually use these rules for implementing server-side routing as well. Because now I can feed more information into the structure, and I can tell which URLs need to be authenticated on the server side. And I can also specify what action should the server do on those URLs, because not all of them, most of them just serve the one-page app, but some of them are special and do a few more things. So I decided, I could execute I could leverage this structure to do more things. And it worked amazingly well for us. It solved all of our problems, and it was very simple and effective. But of course, I had to re-implement the wheel, right? So I wrote the thing. But the thing is that the implementation of the whole thing is here. This is it. It was like 70 lines of code. It's unbelievable. So, of course, I made use of a different library. It's called Crossroads. But it's a very, very simple library. It just does URL parsing. I shoot a URL string to the library, and it comes back. I use it in a way that it comes back with just a JSON dictionary that is the parsing of the URL, and that's it. And then I implement this very legible methods that are like for creating URLs or for parsing URLs, and it's not even very brilliant implemented, honestly. So I could do better than that, but it's really, really simple. And I guess the bottom line, what I learned is that parsing URLs is so simple a thing. Why should we complicate our lives with creating useless abstractions on top of it? It's a simple thing. Let's keep it simple. It is possible, and I'm not gonna use React Router anymore. This has worked out so well for us. So as I said, it's been a little bit harder to implement, because I had to spend those 2 days. Otherwise, if you go by the manual and you install React Router, in 2 hours you're up and running, because you just follow the... So it takes a little bit of effort in the beginning, but you end up with something that's so much simpler. It's got so much less coupling, and it's got less magic, it's more configurable, it's more predictable. And I do have still have an external dependency, of course, but the dependency now is on Crossroads, which is this thing. If they decide to pull it off the NPM, I might as well re-implement it myself. It's not that complicated. It's just a simple URL parser. If I had to re-implement React Router, good luck with that. I don't even know where to start from. So I guess the takeaways for me were, don't use a library just because everyone else does. Think about it and see if you can do, you can spend more time and do something that's simpler, inherently simpler. And then think about the complexity that a library yields. It's not about the API itself, but if you use something that looks simple and easy to use, what does it mean in terms of complexity that it generates? It's not easy to see that. It's very hard, actually. But do invest some time and energy early to build something that's simple, because it will pay back in the end. So it will be slower at the beginning. We invested a lot of time to lay the foundation of this new greenfield project, but it's paying back, because it's easier and easier to add things as we go. And just remember dependency inversion principle. And this is it. So if you have questions, I'm all here. Yeah.
How do we enforce this? Because, as we all know, if you don't make sure that people are actually doing that, they won't do it.
I have no idea how to enforce it. It's, I mean, for me, it's as I said, I had the privilege to work on a greenfield project, so for me it was much easier because all of these concepts I maturated over years, and I had this idea of how software systems should be. But then you know, you always end up working with something that's already started by somebody else, and there's no many ways to do something right from the beginning. So for me, this was a very good opportunity to learn and practice a few of these concepts. But it's really up to the developer in the end. So it's a matter of culture, and of course you can do code reviews. Code reviews are really nice because you can see what somebody else does. If you don't understand what somebody else does, it's probably not that simple. That's one good rule of thumb. Another good rule of thumb is the other thing, like if you see an import of a library in more than one module, it's wrong. It's in the end it's software engineering practices. There's many ways to enforce them. Not many ways to enforce them. Many ways to adopt them. Yep.
How do you keep a balance between like using some third-party libraries and making your own? Because it's like you need to keep balance with this. How do you, in development practice, how do you decide what to use in a specific way? Because actually, all these principles are just basic software architecture principles like flow, coupling, and reducing dependencies and all this stuff. And all of these were previously very well developed. Yeah? And how in usual practice do you decide how to make this balance to be on
Yeah, very good question.
not to fall from
Yeah. So for me, I basically judge it basing on the number of hours I spend in documentation. Mm-hmm. So if I go back to something, so some library over and over and over and over, because I always forget about the API and what the library does, then it better be a really useful library. Because otherwise, you may just as well try re-implementing your own, because stuff that you write, you're going to remember. Stuff that you don't write, you have to look up. So for me, I found that sometimes, like left pod, probably you shouldn't use. That's simple enough, right? It's just a function, just write it. I mean, we're coders, so. But if it's something, it's this React router thing. I was looking at the documentation back over and over, and one day I decided, let's just try and implement it myself, and it turned out to be pretty simple. So that's a good rule of thumb.
Follow-up question: is it scalable? Does it depend on the number of the team? For example, taking such solution now for example, making a homemade library. Is it scalable, or what needs to be done to make it scalable? Like if, for example, the team size increases drastically, yeah, right. Then probably you should write some documentation, some held some talks, tutorials.
Yeah. In the end, it's back to the documentation thing. I mean, it's if you're tempted to roll your own, then it better be really simple. Because then you don't want to reinvent the wheel, definitely. So if you roll your own and you're in a big team, then you write your own internal library. Then you better document it. And if you don't document it just as well as an external library that you may find, then it's not a very good balance. So if you write it internally, it should be well written. It should be simple. It should be well documented. Because otherwise, maybe it's better to use an external library that's well documented if it is. So it's a hard balance to strike, yes.
So actually, you should contest with these library writers, yeah.
Right, but if like my personal taste,
in perspective.
Yeah, but my personal taste, for example, is that if I'm looking at a code that I'm not familiar with, I'm much happier to follow the code and jump from one function to the other in the same code base, rather than stumbling onto an external dependency and having to go and look up the documentation, the external dependency. So I would be happier to find out about some feature that's internally implemented, even if it's maybe a little bit convoluted, rather than stumble into an external library that I have to go and look up. unless it's a very well-known library and very well documented.
So the basic approach is how much hours are spent on documentation.
Yeah, and spreading the knowledge.
I think partially the answer was in your presentation, because it's per weekend. So it's often like that. If you ask a manager, may I just rewrite this thing myself? Often, why we cannot use what we already have? But if you have a question and it's per weekend, you can do stuff and.
Yeah, I mean, if it's a matter of justifying the time you spend trying to rewrite something because you think it's simpler, actually, it's never going to be easy to convince your boss or something if you work for an organization that doesn't give you much freedom. But think about the fact that simple is, in theory, is an objective measure of the code. So you can actually show that something is simpler if it doesn't have dependencies. And you can technically show that dependencies aren't there, or as opposed to being there. Then it's a matter of if the boss understands what you're talking about, but that's a different thing.
But on the other one, you actually target the long-term maintainability. Because if you need to have your MVP very quick, most likely you will go for simple to achieve this level. So. Very good presentation. The first part actually was kind of very close to what is known in like Java community or in architectural community as hexagonal or clean architecture.
Absolutely. Absolutely. I mean, as I said, it's no new stuff by any means. I just wanted to do a little recap because it's. I find it's good to sometimes go back and thinking about the software design patterns because sometimes it's code and you say, oh, this came out plus. Oh, this is actually the inversion principle. So it's good to think about those concepts and keep them in mind fresh. Any other questions?
In the Java world, there are people writing those facades for you, like for logging. Do you see something similar happening in the JavaScript world? That somebody already writes them adapted for you? You can switch logging implementation to.
You mean?
I mean, for instance, SLF for in Java, which is a logging facade. It's a line. That's also another line. Is there something similar in the JavaScript?
Oh, I see. Well, I don't know. Maybe. I mean, NPM contains everything, so I wouldn't exclude it. But if it's another external library, then it sort of defeats the purpose. What if they decide to change the API? Then you have to deal with it, right? So logging in particular is something that's so simple. Like the API of logging should be so simple, in my opinion, that I don't see any reason why you shouldn't write your own little wrapper with those 4 or 5 methods that you need in your application, like log info, debug, error, whatever else, and just use those and implement those in terms of some whatever other library you want.
Isn't that simplicity the reason why you wouldn't write such a wrapper? Because you can't imagine your library that you're using changing the API because it's that simple, right?
Yeah,
Isn't that
but
an argument against it?
no, because the example I was making was actually a real world example. We really wanted to switch from Bunyan to Winston, but the API of the two libraries were different, and we didn't know because we spread out the API in our code. We didn't know how we were using it. So
what was the reason for the move from one library?
the reason was that we wanted to stream the log events to Logmatic, which is one of these services. And there was a very simple to use library that does that for Winston, but we couldn't find the same simple library for Bunyan. And so we would have had to roll our own with Bunyan, implement something that probably around 200 to 300 lines of code. Not a big thing, but still, like the other, it's just an npm install away kind of thing, and so it would have been really convenient. So in the end, we ended up writing a Bunyan to Winston to Logmatic thing. If we had a wrapper, it would have been much cleaner. Let's put it this way. Yeah.
So, bit off topic maybe, but I happen to be the organizer of the closure community in Amsterdam, and you started with a quote from Richiki. So, what's your opinion? What's your take on the closure script?
I never used it, and I regret it. I'm really curious. I mean, I think it's from all I've heard and read, it's supposed to be a really great language. So I would really like to try it. Then again, it's a matter of choice. I think you can still write decent code in pretty much any language if you do the right thing. So it's not. I'm growing less and less language. How to say? I'm not fighting for a language that. Yeah, I've had my fair share of fun with JavaScript. So far, it's good. Okay, thanks.